Every app you build has to put its data somewhere: the photos people upload, the videos, the backups, the database. And AWS doesn't give you one place to put it, it gives you a whole family of storage services. Beginners mix them up constantly and pick the wrong one, and either overpay or hit a wall. So over the next few minutes, we'll sort the whole thing out, with pictures, S3, EBS, EFS, and Glacier, what each one actually is, how it works under the hood, and exactly when to reach for it. By the end, you'll never confuse them again. Almost all of AWS storage comes in 3 flavors, and getting this distinction is half the battle. First, object storage, that's S3. Think of a giant warehouse where you drop off whole files and never think about disks. Second, block storage, that's EBS, a raw hard disk you attach to a single server, just like the drive in your laptop. And third, file storage, that's EFS, a shared drive that many servers can mount and use at the same time. Object, block, file. The entire game is matching the right one to how your data needs to be accessed. Let's start with the star of the show, S3, the simple storage service. It's object storage, basically an endless warehouse for files. You can store anything: photos, videos, backups, log files, entire data lakes, as much as you want, with no capacity to plan, and you pay only for what you actually store, by the gigabyte. The catch that trips everyone up is this: you do not mount S3 like a drive on your computer. There's no C drive, no folder you drag files into. You talk to it over the web, through an API, your app makes a request to upload or download an object. And now, the single biggest S3 myth, so really listen, because almost everyone gets this wrong. S3 is not folders inside folders, it is completely flat. The right mental picture is a coat check at a theater. You hand over a whole coat, a whole file, and you get back a numbered ticket, a key. To get your coat back, you show the ticket. Those slashes you see in a file's name, like photo/2026/cat.jpg, look like folders, but they're fake. It's all just one long key, one flat label. That's also why you can't edit a file in place. You can't open an object and change one line. You download the whole object or you upload a whole new one to replace it. So if it's just files sitting on the internet, can you lose them? Almost never, and this is where S3 quietly shines. The moment you store an object, AWS automatically copies it across multiple availability zones, multiple separate physical buildings, miles apart. They quote a number called 11 nines of durability, 99.9, with 9 more nines after it. What that means in plain English is that you could lose an entire data center to a fire or a flood, and your files would still be perfectly intact, served from the other copies. You don't configure any of this, it's just how S3 works. Now, here's a money lesson, because not all of your data is equal, and you should not pay the same for all of it. S3 has storage classes, different tiers at different prices. Standard is for hot data you read all the time, your live apps photos. Standard infrequent access is noticeably cheaper, for things you touch only now and then, last quarter's reports. And Glacier is a deep freezer, dirt cheap per gigabyte, meant for old archives you almost never open, where you're fine waiting minutes or hours to pull something back. The skill is simply matching the class to how often you really use the data. And the beautiful part is you don't shuffle data between those tiers by hand. You write a lifecycle rule, one small policy attached to the bucket. For example, after 30 days, move this object to infrequent access. After 90 days, push it into Glacier. After a year, delete it entirely. Then AWS enforces it automatically, every single day, in the background. You set it once and forget it, and your aging data quietly slides itself down into cheaper and cheaper storage without you lifting a finger. Let's make the savings concrete, because the numbers are dramatic. S3 Standard runs a bit over 2 cents per gigabyte per month. Glacier Deep Archive is closer to 1/10 of a cent. So imagine PhotoApp has 10 terabytes of old photos that nobody has opened in a year. On Standard, that's roughly $230 a month forever. Move it to Deep Archive with a single lifecycle rule, and the same 10 terabytes costs about $10 a month. Same files, same durability, just a different shelf in the warehouse. That one rule pays for itself in the warehouse. A short but absolutely critical word on security, because this is where companies end up in the news. Every new S3 bucket is private by default. All public access is blocked from the start. When you hear about a leaked S3 bucket exposing millions of records, it is almost never a hack. It's someone who deliberately turned off the protections and wrote a bad policy. So the rules are simple: leave block public access on, open up access only deliberately to specific identities, using a policy or a pre-signed link, and switch on default encryption, so even at rest your files are scrambled. Private first. Public only on purpose. That covers object storage. Now block storage, EBS, the Elastic Block Store. This is a virtual hard drive that you attach to exactly one EC2 server. To that server, it is indistinguishable from a physical disk. The operating system boots from it, databases write to it, you save files to it normally. A couple of things to keep straight. An EBS volume lives in a single availability zone, and it attaches to one server at a time. And they come in types. General purpose SSD, called GP3, is the sensible default. Provisioned IOPS, called IOPS, called IO2, is for databases that need guaranteed high performance. Because an EBS volume is tied to one server in one zone, you protect it with snapshots. A snapshot is a point-in-time backup of the entire disk. And here's the elegant part, it's quietly stored in S3, so it inherits all of that 11.9's durability we just talked about. Snapshots are incremental. The first one copies everything, but every snapshot after that only saves the blocks that changed, so they're cheap. And at any moment you can create a brand new volume from a snapshot, in a different zone if you like, which is exactly how you recover from a failure or clone a server. So S3 is for objects over the web, and EBS is one disk for one server. But what if a whole fleet of servers needs to read and write the same files at the same time? That's the job of EFS, the Elastic File System. It's a shared file system that many EC2 instances can mount together, all of them seeing the same files live, like a shared network drive in an office. It grows and shrinks automatically, so there is no capacity to provision. It costs more per gigabyte than S3, so you don't dump archives in it, you use it specifically when servers must collaborate on one common set of files. So, decision time, here's the cheat sheet you'll actually use. Reach for S3, object storage, for almost everything, anything served over the web, backups, logs, and anything large because it's the cheapest and the most durable. Reach for EBS, block storage, when a single server needs a fast local disk to boot and run a database. And reach for EFS, file storage, only when many servers must share the exact same files at once. 90% of the time the answer is S3, the other two are for specific jobs. Object, block, or file, it always comes back to how the data is accessed. Let's anchor all of this on PhotoApp. The photos and thumbnails your users upload go straight into S3. Cheap, infinitely scalable, 11.9's of durability, and easy to serve to a browser. The EC2 server that runs the app boots off an EBS volume, that's its operating system and code. You take nightly snapshots of that volume into S3 so you can rebuild the server in minutes. And a Lifecycle rule watches the photo bucket and quietly retires albums nobody's opened in a year down to Glacier. One app, 3 storage services, each doing precisely the job it's best at. Here's the whole storage picture in one diagram. A user uploads a photo, it lands as an object in an S3 bucket. The web server runs on an EC2 instance whose disk is an EBS volume, and that volume is backed up by snapshots, which themselves live in S3. Meanwhile, a Lifecycle rule continuously sweeps old untouched photos from S3 standard down into Glacier to slash the bill. Notice the pattern, S3 sits at the center, durable and cheap, while EBS serves the one server that needs a fast local disk. That is a real production storage layout. Let's bring the whole thing together. S3 is your object warehouse, files go in, keys come out, copied across data centers for 11.9's of durability. Storage classes and Lifecycle rules automatically slide cold data into cheaper tiers, and every bucket is private and encrypted by default. EBS is the fast local disk for a single server protected by incremental snapshots that live in S3. And EFS is the shared drive for when many servers need the same files. Object, block, file, you now know exactly which is which, and when to use each which is which, and just 3 is called data into cheaper tiers. And that is AWS storage, sorted. Not a pile of confusing acronyms, just 3 ideas, object, block, and file, each with a clear job. If S3 and its family finally make sense now, do me a favor and subscribe to Viaan Cloud, because the whole point of this channel is taking the scary parts of AWS and making them simple, with pictures. The next deep dive is Compute, EC2, and Lambda, where your code actually runs. Tell me in the comments what you want me to break down, and I'll see you in the next one.